Now you're given a function like f of x is equals to 1 over the square root of x. You're told to find dy over dx using the first principle method. Now, what is the formula of the first principle? The first principle formula is derivative of f of x is equals to f of x plus h minus f of x all over h. Limit as h approaches 0. Now, note that h is equals to change of x. They're both the same thing. They can be interchangeable. Change of x can be equals to h. You can use change of x, which is f of x plus change of x minus f of x all over change of x. But h is obviously more convenient and easier to use, so we will be using it over here. So if this is the formula, then let us begin with this problem. Now we had that f of x was equals to 1 over x. So let's do f of x plus h first. Doing f of x plus h, you're going to be getting 1 over the square root of x plus h, meaning that wherever you see x, you add h to it. X plus h minus f of x. This is the second thing the formula says, and we have already established 1 all over the square root of x plus h. The next thing we do is we subtract f of x. So this is going to be minus 1 over the square root of x. Now, over here, we're going to take LCM, square root of x plus h, square root of x. So over here, we're going to be getting x minus square root of x plus h. So this is what we get. What do we do here? We rationalize this function, and we use the one at the top. This on the top over here. So we're going to multiply this by x plus square root of x plus h all over square root of x plus square root of x plus h. So this is it. And this one to multiply this one plus square root of x plus h minus square root of x plus h square root of x plus square root of x plus h. You're going to be having this. So let's work with the numerator. We come back to the denominator later. So this is the numerator, and this is the denominator. Multiplying this, you're going to be having x, because the square root of something times the square root of something is equals to that thing. So plus square x plus h minus, multiplying this by this, you get minus the square root of x, square root of x plus h minus square root of x plus h times the square root of x plus h is equals to x plus h. So simplifying this, you're going to be having x plus square root of x plus h minus square root of x plus h minus x minus h. So at this juncture, this one cancels this one. They're literally the same thing. So what you're going to be left with over here is x minus h. So it's going to be x minus h all over the square root of x, square root of x plus h, square root of x plus the square root of x plus h. So this is equals to f of x plus h minus f of x. So the next thing we do is to divide by h, as the formula states. Minus h over the square root of x multiplied by the square root of x plus h multiplied by square root of x plus h plus square root of x. You're dividing all by h. So once you divide all by h, you get minus 1 over square root of x, square root of x plus h square root of x plus h plus square root of x. Now this is equals to f of x plus h minus f of x all over h. So the next thing we do is to get the limits as x approaches 0. The f of x plus h minus f of x all over h as h approaches 0. So to solve this limits question for this one, which is minus 1 over square root of x plus h square root of x multiplied by the square root of x plus h. What you do here, you just substitute 0 into the h wherever you see h here. So it's going to be equals to minus 1 over square root of x multiplied by square root of x plus h, which is x plus 0, is equals to x multiplied by square root of x plus h is going to be equals to x plus 0, which is x plus square root of x. Doing this, you're going to be left with going to be equals to minus 1 over square root of x times square root of x. It's going to be equals to x multiplied by square root of x plus square root of x is equals to 2 root x. 2 root x, because 1 plus 1 is equals to 2, x plus x is equals to 2x. So root x plus root x is equals to 2 root x. It's going to be equals to minus 1 over, remember that x ordinarily is equals to 1, but root means raised to the power of 1 over 2. So using indices, you're going to be having 1 plus 1 over 2 and raised to the power of 3 over 2, which is going to be minus 1 over 2x raised to the power of 3 over 2. You have your final answer over here. Let's check if we're going to have the same answer if we do 1 over the square root of x using the normal derivative test. So it's going to be equals to 1 over x raised to the power of 1 over 2, which is equals to x raised to the power of minus 1 over 2. Now multiplying x by raised to the power of minus 1 over 2 and subtracting 1 from negative 1 over 2. It's going to be equals to minus 1 over 2x raised to the power of minus 3 over 2. Simplifying this further, you're going to be having minus 1 over x raised to the power of 3 over 2 multiplied by 2. That's your final answer. Now, for the one we did previously, which is equals to this, your final answer can also be in the form minus 1 over 2 square root of x to the power 3.